Okay, so now we're discussing derivative trig functions. And we'll do pages 1 and 2. So d dx means derivative sine x, d dx means derivative cosine x. And we could use our TI calculus to graph the derivatives. So sine x, if you're to graph that, looks like that. Now if I do the derivative of sine x, so I should have had the TI calculator open in advance, my apologies. So let's go over here. It's taking a sweet little time. I think it'll tell me I have about 40 days to buy a license. I don't know if I want to do that. Maybe I will. I'll talk to the school about it. Okay. So remember, I'm going to put sine x here. You do have to be in radian mode, by the way, which I am. And remember, I do this. I do alpha window, option 3, put an x there, alpha trace, put a y1 there, hit the right key, put x there. And I'll graph in the z trig window. So you can see that that's sine, and then the other one's giving me the derivative of sine. So I hit the trace button. If you kind of look at that, does anyone know what that graph that looks like, the derivative of sine? Does anyone want to just put in the chat or maybe speak in the microphone? What does that derivative of sine look like? What kind of graph does that look like? So I see some chats here. Yep, it's cosine, 100% correct. That's totally cosine. Now let me reverse it. Let me make that cosine. Let's see what happens now. There's cosine, and there's an x graph. Let me turn off the cosine because it's a little confusing. Now, what do you think that graph looks like? The derivative cosine. It starts going down, then up, and it's obviously at the origin. What do you think that graph represents? Or what equation is being represented by that graph? It's negative sine x, very good. It's not sine, it's negative sine, so sine flipped over. So just by graphical inspection, we can easily find these derivatives here. So I didn't really need to do a drawing here, that was kind of useless. The derivative of sine is cosine x. The derivative of cosine is negative sine x. And we must be in radian mode, very important. The results won't be true if you're in degree mode. Why exactly? There's a more formal definition. That we'll have to wait for a while to discuss that. I'm not ready to do that discussion today. And the video doesn't get into that formal reason, but you have to be in radian mode. Now we can prove these results, and we'll do so later in this section if we have time. Well, actually, I do an analytical derivation of sine and cosine in the video, just so you know. That's the video you guys will watch for homework. Now, derivative tangent. Now remember, does anyone remember the identity for tangent x from pre-calculus or algebra 2 trig honors? If you forgot, it's just this. That's an identity. So basically, you're doing the derivative of sine x or cos x. Well, guess what? What rule am I going to use here? What rule can I use to find that derivative? Anyone can chime in. Quotient rule, perfect.
Quotient rule.
Yep, you use the quotient rule. Outstanding. So remember, it's low d high minus high d low over low square, and away we go. So, okay, don't worry about the spelling. It's all good. So the derivative of sine. So you basically do the low d high. So I'm going to kind of do this to show I'm taking the derivative of sine x minus the high times the d low. So I'm showing the derivative of cosine x over low squared. Now, derivative of sine we now know is cosine. So you have cosine x. Let me switch that to blue. Times cosine x minus sine x. Derivative of cosine is negative sine, so I'm going to switch that to negative. And remember, there's a times there. And divide by cosine squared x, which now we kind of sometimes write like that because it's just a little easier to write like that, just more notation thing. Well, guess what? You have a minus and negative going on here. So you have cosine squared x. Minus and negative becomes positive, so positive sine squared x over cosine squared x. Now another identity, very important. Does anyone know what this identity equals? Cosine squared plus sine squared.
One.
There's just one. This is called the Pythagorean trig identity. That's just one. So you get 1 over cosine squared x. Yeah, remember another identity that's important to know, cosine squared x plus sine squared x. I don't expect you guys to know too many identities, but these two I kind of expect you to know. Sine over cosine is tangent, cosine squared plus sine squared is 1. And also the reciprocal trig identities. When you have 1 over cosine, what is that as a reciprocal trig function?
Secant squared x?
Yep, there you go. 1 over cosine is secant, but it's squared, so it's secant squared x. And so the derivative of tan x is secant squared x. So that's derivative tangent. So it's not just, I don't want to just tell you, oh, it's just this and that's it. I want to kind of make sure you use some of the trig you've learned last year or 2 years ago if you took Algebra 2 trig honors, which should have been reinforced obviously in pre-calculus, AB honors or BC honors, whichever one you did. You know, just so you can see why these things work the way they do. So derivative sine is cosine, we saw that graphically. Derivative cosine is negative sine, we saw that graphically. Derivative tangent is secant squared x. We've done that analytically using our identities that we know for tangent and using our quotient rule, which we learned in the previous unit. So, you know, everything's kind of building upon itself here, right? It all comes together quite beautifully. Okay. Any questions so far? Nope. Okay, we're going to start applying this to some problems in just a tad. Now, these other ones here, you know, you could just, they're not too complicated. I'm going to kind of just tell you straight up what's happening here. Now, if you do derivative cotangent, that's going to be negative cosecant squared x. If you do secant, that's going to be secant x times tan x. And if you do derivative of cosecant over cotan is 1 over tangent. I believe it's negative cosecant x times cotan x. And the best way I remember this is my cheat sheet. I have a little cheat sheet here, which I'm going to share with everybody in just a little bit. I think it's right here. AP Calculus AB, fall semester, probably under test, final exam, no. Hold on a sec. I'm gonna be a little bit annoyed if I can't find this. Cool, found it under miscellaneous. Derivative rules and formulas, remember. So this is gonna be a very nice little cheat. So if some of you guys have been asking for like ways you can summarize things, boom, there you go. You should be able to know everything on the first page for the most part. Chain rule we're talking about later on, so it's good to give it to you guys anyway. We're gonna do inverse functions. We'll have that linear motion stuff. All the trig stuff is right there. We'll do inverse trig functions. We'll do log functions. So this is going to be your best friend when we have our test on this right before Thanksgiving. I'll put this in Schoology. I'll probably put it in the main page just so you have it there. But yeah, I mean, I remember this one just because, you know, I do this for a living, right? I teach and stuff. But you know, if you're away from calculus for a while, you kind of forget the derivative of these guys here. And to actually work these out, you actually would have to do what we did in the example above with tangent x. I don't want to do that for this 3 times because that's very redundant. I trust that if you wanted to do a quotient rule for each of these 3, knock yourself out. You want to do quotient rule here, here, or here, go ahead. You could do that. And remember, 1 over tangent is also the same thing as saying cosine over sine x. So if you kind of did the same thing we did for tangent x for that derivation of that derivative, you would get these results here, just so you know. Now we're going to use this to do examples 1, 2, and 3. And we should wrap up right before class gets out. Pages 3 and 4 are done as a video. I just finished making the recording, but it won't download until I close Zoom, then I got to upload to YouTube. So it should be ready by later this morning. The rest of the homework, homework 16, is set, the Google form, as well as the textbook problems. We got to watch the video first. So I should have all this set pretty soon. So if you want to maybe squeeze this in during lunch or early in the afternoon, then watch elections, because I think a lot of us can be glued to the TV tonight. Anyway, let's go over this one here. So to find this derivative, I'll call it y prime because I'm lazy, but dy dx, same thing. Remember, same as y prime, just a notation thing. So I got a product rule here. I need accent marks to show I'm taking the derivative, and of course, your cosine is negative sine x. Remember, this right here is product rule, right? Product rule is to take the derivative of one thing times the other kept intact, plus vice versa. Well, derivative of sine is cosine x. Derivative of x is just 1 straight up. And of course, I got negative sine x. Well, sine x and negative sine x cancel. So the answer is just going to be x times cosine x. Now remember, you can verify this using your calculator. So remember, I had an x times sine x plus cos x. And the answer we got was x cos x. I'll turn off the first function. Make sure I graph in the trig. So there's the first one. That's the derivative of y1. And the second one, I don't see it. And that's a good thing. You should not see it because it should be the same thing. If I hit trace, hit the down key, y3 is the same curve. They overlap. They should overlap if you do this correctly. So this is the way we verify our work. This is how you feel comfortable and confident, because there's a lot of stuff you're doing, right? I mean, did I do the product rule correctly? Do I remember my rules correctly? Did I make some stupid, careless mistakes or algebraic mistakes? You know, we're human, right? That's how you can check and verify your work. And I strongly recommend you do that on our next assessment, or just doing homework in general. Here's another question that you could be asked, like, hey, find equation of the line normal to this. Well, normal means, you know, well, first of all, we need an equation of a tangent line, but you got normal, so you got to do a perpendicular slope. So let's find our derivative first. That's going to be m, is going to be the value of that derivative. And remember, cotangent was negative cosecant squared x. I just gave you that formula. We do negative cosecant of pi over 4, that being squared. Your unit circle, sine of pi over 4, if you remember, is root 2 over 2. So cosecant of pi over 4 is that flipped over, which actually could be rationalized to just be root 2. So the negative of root 2 squared. We square the root 2 first, which is 2, and then do the negative after that, following the order of operations. That's going to be 2. Sorry, negative 2. So your perpendicular slope is 1/2. So the equation of your tangent line is going to be y minus cotangent of pi over 4, in case you guys forgot, is 1. So it's y minus 1 of 1/2 x minus pi over 4. That's the normal line, mind you. Any questions of what I just did for example 2? Again, took the derivative, which I knew, just used, you know, the form I just gave you on the previous page. Then I did some trig, you know, did pi over 4, Cosecant pi over 4 is reciprocal of sine pi over 4. Sine pi over 4 is root 2 over 2. So flip that over, you get 2 over root 2. Rationalize, you get root 2. Plug it in, work it out, you get -2. But that's the slope of the tangent line. I want the normal slope, so I got to do negative reciprocal. Then I do point slope 1. And I get the y coordinate at pi over 4, plug pi over 4 into cotangent. Now, if I were to quickly graph that, maybe I'll do that in Desmos. Y equals cotangent x. And if I do my tangent line, y minus 1 equals 0.5 x minus 0.25 pi. Yeah, so we see that pi over 4 is right there, and that does look like a normal line because the tangent line would probably be kind of like this at pi over 4. And that had a slope of -2, so that totally makes sense. I feel pretty good about that. So you can use Desmos to feel comfortable with your work. Okay, last example, then we'll wrap up class. Here you're asked to find the derivative of u. I mean, it's just u prime, just so you know. So you got to do a quotient rule again that we did on the previous page. So low d high. So derivative of cosine is negative sine x minus high d low. Well, derivative of 1 is 0, and derivative of sine is cosine, but there's a negative attached to it. You know, there's a negative from the, this part right here, right? All over 1 minus sine squared. Sorry, 1 minus sine x squared. If you clean it up, you get negative sine x plus sine squared x, because you have negative sine x times negative sine x. And here you have negative cos x times negative cos x, that's plus cosine squared x. And the bottom, I'm actually going to rewrite like this. Because hopefully you can see what's happening here. What's sine squared plus cosine squared? 1, right? So now my derivative becomes 1 minus sine x over 1 minus sine x times 1 minus sine x. And both those 1 minus sine x's cancel. So the final answer is 1 over 1 minus sine x. And that's going to be the derivative of this function right here, which again, you can verify in the calculator. And you already know how to do that. I already showed you how to do that, so I don't need to do that again. But that's going to be the derivative of 1 over 1 minus sine x. Now, unfortunately, we did not get a chance to review the textbook problems from homework number 15. We'll save that for Thursday because the homework that I'm assigning is really short and real easy. I don't imagine there'll be many questions, so I'll make sure I make time for that on Thursday. And I think that's pretty much it for today. It is 10:10. So let me stop this recording. Stop sharing, stop recording. Okay, so I'll make sure I upload all recordings to Schoology for today's class. And of course, the video for homework number 16, I'll make sure that's there as well. You don't see it right now. So if you have a free B period, just wait maybe 15, 20 minutes, and I'll make sure I have that recording up for you guys. If you want to get homework done before the end of today, if you want to watch the election results. And if you're 18, vote. No reason not to. You should do that. If not, then wait till next time around. And I think that's it. And we'll see what happens to our world in the next couple days. Okay, so that's all. I'll see you guys on Thursday for sure. Goodbye.
Thank you.
Thank you, Mr. Reed.
Thank you, Mr. Eat.
Welcome.
Thank you.
Welcome.